Okay, we have written an interesting integral from the MIT integration bee 2006, problem 10. We have the integral from 0 to 1/2 x arc sine x over square root of 1 minus x squared dx. Okay, the first thing I noticed with this problem is just we've got arc sine here in the numerator. That can be difficult to deal with except for the fact that we have the derivative right here. We have 1 over square root of 1 minus x squared dx. So it's making me think if we split this up right here, everything on the right, this is going to be an easy integral because it's all set up for us for like a u substitution. We can differentiate x, so we're in good shape for integration by parts. So I want to do that with the DI method or tabular integration. But now before I do this, when I did this on paper, it was kind of going around in circles. It wasn't very nice this way. It kind of just led me back to the original problem. I don't know if you can get it to work this way, but then what I noticed was if we just split this a different way, kind of do it this way and split the x with if I group the x with the square root of 1 minus x squared, well then we're really close to having another u substitution. If we make this stuff u, then we're close to having du in the numerator. So what I want to do is break it up this way and we'll integrate this piece. So I'm going to integrate x over square root 1 minus x squared, and then we can differentiate arc sine of x. So first I'll just differentiate this piece. This is going to be, like we said before, 1 over square root 1 minus x squared. Then here, for this integral over here, let's just take it off to the side so we're clear what's happening. So we're going to have x over square root 1 minus x squared dx. Now I want to set up that u substitution I mentioned. So what I'm going to need here is, I'm going to need minus 2 in front to make this work, but I'll multiply by minus 1/2, so I'm not changing it. Then we'll call this stuff our u. So I'm going to say u equal to 1 minus x squared. Du equals minus 2x dx. So then when we do this, well, we're minus 1/2 there. This whole numerator becomes du. And then this is going to become just square root of u here. But before I integrate, let's just rewrite it. So I'm going to write it as u minus 1/2 du. We can integrate it using power rule. So on this, integrating this, adding 1, we get u 1/2. But when you take the reciprocal out, so we multiply by 2. So 2 is going to cancel with 1/2. And so for this, we're going to have minus square root of u, but u is going to be just 1 minus x squared. So we'll put this back on the table. We'll have minus square root 1 minus x squared. So now we'll try to finish it off. So we'll have part of the solution on the diagonal. So we'll write this minus arc sine of x times square root 1 minus x squared. And then here, this last row is an integral. But when we do this, minus times minus is plus. Square root 1 minus x squared over 1 minus x squared, this is going to cancel. And now we're just integrating 1 here. So of course, integrating 1, we get x. I'm going to change the order now. We'll have x minus arc sine of x times square root 1 minus x squared. We just need to evaluate this all from 0 to 1/2. Well, now at 0, just notice everything's going to be 0. That's going to be 0. Arc sine at 0 is 0. So we're not going to worry. So we're not concerned about 0. We just need to plug in 1/2. So plugging in 1/2 here, we get 1/2 minus, we'll just leave it like arc sine of 1/2 for a second. And then here, we're going to have square root 1 minus 1/2 squared is 1 minus 1/4. So this is going to be 3 over 4 here. So then we just need to simplify. So we have 1/2 here. Arc sine of 1/2, that's going to be just pi over 6. I can simplify a little bit here. I can square the 4 and we'll have square root of 3 over 2. So this here is going to be 12. Let's just get a common denominator in this. So 1/2 I can write as 6 over 12. We'll write everything over 12 minus pi square root of 3. And that's it. Okay, there you have it. Good problem from MIT 2006. Thanks everyone for watching. Have a good day.